Alright guys, welcome to Codeforces. Today we have a div 3 competition. Should be good like that. Just close it. Okay. Yes, please. I would like to go to the problems and submit. Problem A, shortest path with obstacle. There are 3 cells on an infinite two-dimensional grid labeled ABF. And for what reason decided to put a new line here? That will stop a lot of Python users. So each test contains 3 lines, X, A. Okay. Okay. Say Y, A, Y, A. I should say AX, AY, BX, BY, F, X, FI. Right? So what do we actually need to do? In one move we can go to adjacent cells, and visiting the cell F is forbidden if it is an obstacle. Okay, so the only then whoever came up with that problem is not particularly, I don't know, inventive. That is just stupid. Okay. Can't believe it. So if AX equals BX and BX equals FX or and unbelievable. AI less than FI and like the only that's such a dumb problem, really. Honestly, why would you ever want to create such a mess like that? That's just terrible. It's not a problem that people want to solve. It does not come from real life. It is just dumb. Is it guaranteed that A, B, and C are different cells? They don't. However, okay, they don't even tell you if it is if the cells are different. What are we talking about then? Okay, so the only case in which this extra cell actually can stop us from doing anything we want is when they all lie on the same line, which is either a row or a column, or I suspect actually vice versa, but whatever. And Fx lies in between of them. Then banning us from visiting F means that we have to go around it, adding 2 more moves. So the answer is then AX minus BX plus absolute value, of course, AY minus BY plus 2. Otherwise, such a dumb problem, honestly. Why would you want to create one like this? This is why I never create problems, because I just have a high threshold for what I consider beautiful, and none of problems like that pass the threshold. 4, 6, 41, 4, 4, 2, 334. Oh, the only benefit of having extra new line is that when testing, you actually can see your, like, what is the test case and what is not the test case. Okay, so not accepted for this one. Dump problem, that's all I can say. Spent 5 minutes. We spent 5 minutes on A. Unbelievable. A problem B, alphabetical string, a string s of length n. But in this problem, for some reason, we don't have such a property of having new lines between tests, and I believe it's better when it's consistent. Because in Python, you get a line, not the next integer or next string that appears in input stream. It is just, whoever went for this does not know that Python exists, apparently. So, what are we doing? Each test case consists of one string s. No, they don't even give you a length, so looks like, oh, length is small, okay. Can be obtained using the following algorithm. First, write an empty string, perform the next step n times. At I step, take i's lowercase letter of the Latin alphabet and write it either to the left of the string or to the right of the string. Perform this, okay. And reward it right over first n letters. Can we just say that let's cast whatever input we had into a deck. And then we say like and get string length -1. Not n, but I. If q, no, no, yes. If q front not q empty, no, q will never be empty. Okay, if q front equals a plus I q pop front, else if q back equals a plus I q pop back, else p gets false, then we print yes, no. Yeah, I know I don't particularly care, because string is guaranteed to be offline. Yes, 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 no, 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 thank you. This is also nice input, but imagine that number of no's is wrong. You won't spot it visually, so I don't think that's particular like that good. Okay. Still, you see, like, turns a bit into speed forces. This terrible first problem being implementation. This the first problem being a terrible implementation. Oh, apparently the new standard memory limit is 512 megabytes. I did not notice when this happened. I'm used still to 156. So in case of length n is called, oh wait, we saw this. Should have taken a longer break between AddCoder and Codeforces. So Monocarp and Polycarp are learning new programming techniques. Now they decided to try pair programming. It's known that they have worked together on the same file for n plus m minutes. Every minute, exactly one of them made one change to the file. Before they started, there were already k lines in the file. Every minute, exactly one of them does one of the two actions, adds a new line to the end of the file or changes one of its lines. Monocarp worked in total for n minutes, performed a sequence of actions. If AI equals 0, then he adds. If AI is greater than 0, then he changes the line with number AI. Monocarp performed actions strictly in this order. Same for Polycarp. Restore the common sequence of actions of length. All would be correct. Okay. Fascinating. No, it's simple math, but you have to be careful, I think. Or do you? You don't have to be careful, you just write a dynamic programming. Because constraints are... I'm bad at math. What is this? This is fast enough. Surely this is fast enough. No, I don't have to do anything, right? Right. Sounds suspicious. Yes, I did something wrong apparently this. Okay. Why M? Why? How can I be that stupid after all these years? Okay. dp at I plus 1. Sounds suspicious. I'm doing something terrible here, but I guess it works. No, I'm clearly doing something wrong. That should not be like that. Why is this so annoying? Like, I'm not trying to do anything strange and it's still annoying. Usually when something is annoying, it's because I'm doing something wrong, but here no. Like, the problem in itself is annoying. No, I need... I need these guys. No. Okay. Unbelievable. Index work is just... Okay, so 0, 0 equals k. Good. Still not. Problems are so... Either the problems are so bad today or I'm very dumb. And I'm not sure what is true. Surely I should be able to do the following. So I say dp at I plus 1 0 gets dp at I 0 plus AI is equal to 0, parent of a plus 1 0 gets 0. 0 equals A, 1 equals B. Why is the implementation so annoying? Or am I, like, I must be doing something suboptimal here, but the problem should not be annoying. Not that annoying, please. It's not what people come to Codeforces for. Because that's not what I would prefer to use it for. Okay. See, this time it's J. This is less than that, then it should get equal to that. Okay, and parent of I plus 1 j should be 0. You should never copy paste like that, it's just so error prone. I think it should be j plus 1. Whoever came up, like those new guys, don't trust them, they are not preparing good problems. Previous div3 was much better. Okay, now what do we do? Is it where it should be? It is, right? Unbelievable length of the implementation for C. Simply unbelievable. How you can even my ideas are less bad for problems, I mean. If parent at ij, if parent at ij is equal to, if parent at ij may as well use while parent at, no. If parent at ij, it means it's 1. So R should get pushed back. 1 is bj minus 1. Else R pushed back ai minus 1. Here j decreases, here I decreases. So we constructed a path that achieves longest possible length of the file as early as possible. I think. To achieve the longest possible length of file as quickly as possible. It's a bit strange. It's a bit, oh, I should have checked here. Oh. Unbelievable. Okay. Okay. I just so done. I honestly want to close this problem, this contest, and just go. I'll take a walk outside. It will be much better for my mental health, apparently. Because this is just ridiculous. Okay. Okay. Wait. So bad. I have never seen a worse implementation problem in my life. I honestly can't remember a worse problem. Okay. So, if, like, we have to check actually if AI is less than or equal to dpi0. No. First, we have to check that it's reachable. Then we check that it's fine, and only then we can perform this operation. Like, guys, you don't have no idea what a beautiful problem is. I don't even know why I solve problems that you created. I don't want to. Not anymore. Okay, so dp contains either -1 if it's impossible to satisfy the construction, or the length if it's possible. If it's possible, then we don't care that much. If it's impossible, that's possible. So here, if dp at I j plus 1 is not equal to -1, and ai is less than or equal to dp at I j plus 1, dp should get to that. Oh, we don't have to care, like we just check if it's possible to add or if it's not possible. Well, at least something is not that bad about this problem, but I still don't like it a lot. Like I actively hate it. Unbelievable. Imagine getting wrong answer on this one. You will die debugging. Because we don't need it. Turns out we don't need it. Turns out that problem is so bad that we don't need it. Okay, what are our answers again? 2005, 20, wait. Print any correct common sequence. Okay. So here we have what's the input order again? Initially there are 4 lines. Monocarp makes 3 changes, polycarp makes 2 changes. Changes are 205 and 06. So 20506 is valid. Here we have 4, then we add 5th line, then we added 5th line, we add 6th line, we added 6th line. Here -1, here the answer is 06, 07, 08, 09. Here the answer is -1. I'll spend eternity on that problem. Unbelievable. 20 minutes simply. Why? What does it teach people to do? Everybody except for me skipped it because they hate it, and I just have only I have strong, I don't know, will enough to do such terrible problems. Co-growing sequence. I'm gonna solve it so I can as well. Sequence of non-negative integers is called growing if for all I from 1 to n minus 1, all ones of binary representation in AR I in places of ones in AI plus 1. Excuse me? So we can only add more ones to binary representation. Okay. Yes, we just add a bunch of ones. Or we change nothing, okay. We either add a bunch of ones or we change nothing. Consider two sequences of non-negative integers. Call pair of sequences co-growing if the sequence is growing where O plus denotes XOR. Given a sequence X, find the lexicographical minimal sequence. Why such sequences are co-growing? What's the trick? What is the trick in this problem? So like we can change whatever you want. It's always possible to find at least one such sequence y, for example, yi equals xi. Okay, not particularly intellectual problem, I believe. Because what happens is the following. Yeah, no, problems today are just bad, so I don't know. Interview style. Take it as an insult. Interview style. That's what Codeforces is today. So, knowing bit problem, right? What I claim is that xi. Okay, let's say this. So equals x0. We have some mask. Mask denotes what was the previous element, which is not particularly useful, but what was the, let's put it this way. Mask denotes what was the previous element of the XOR sequence. Justifies its existence. So what do we want? We want so that xi is as a mask, superset of n. So it means that some bits of y have to be flipped and some have to be unchanged. Makes sense, right? So let's iterate over bits. If xi if this bit is not turned on and this bit is turned, if it's not turned on in xi, but it is turned on in our mask, then it has to be turned on in y, so that XOR gives us whatever we want. Now, What is next? Can we make yi any smaller? No, 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 no. You can't. You can't. You have to set some bits, and you're free to go. And because it lacks a graphically minimal, you just do greedy. Unbelievable problem quality, honestly. So, no, I don't want to assort. So this way, I'm sure that if a bit is on in mask, then it's also on in xi XOR yi. Update mask. Zero, 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 zero makes sense. 0, 1, 3, 7 makes sense. 0, 1, 0, 3, 2 makes sense. 0, 2, 0, 4. Okay. Boring. I am starting to lose an idea of why I'm doing this contest. If I'm honest with you, it does not sound interesting. Orion. It's tough. It's tough. But honestly, it sounds boring so far. Air conditioners. On a strip of land and okay, air conditioners. The ice air conditioner is placed in a cell AI. 2 or more air conditioners cannot be placed in the same cell. Yeah. It asked all AI are distinct. Each air conditioner is characterized by one parameter, temperature. I don't know about your air conditioners, but my air conditioner has much more parameters. And it's important for it. So temperature is Ti. For each cell, find its temperature that can be calculated by the formula minimum of Ti. Okay, so like this is 14, then it's 15, 16. Okay. That's it. Boring interview style. And it is starting to become a real insult for you. The only good thing in this contest is this input format. Surprisingly. As much as I don't like it as a Python user, because you have to make one extra input, just ignore it, which is not nice. I like it as a C++ user, because with local testing, N is not Linux. Bro. Nah. Okay. I understand why people skip to F, because 5 first problems are just dumb implementation. I am very disappointed. very. Okay, oh. This cycle is supposed to balance. Loop. Cycle is mathematical loop. TAI gets TI. Good. Deck. I think because of the line sync, it can be just deck. Oh. Oh. May not be that simple. Imagine a test case that goes like this. Like that, there's no condition. No, just like this. So the correct temperatures for this case are like this, right? What happens if you make all of the changes with a simple BFS, and this updates this updates this updates this updates this. Okay. Let's just don't think about it and write the extra. Greater, right? Greater. And call it BFS for hackers to wonder, he used BFS, we will hack them. But that's the extra. Okay. In place. As usual, I'm stupid. Of course it's pair, always has been pair. What do we in place? TI, AI. Right? Right. While not BFS empty. TI, AI. No, but it's like temperature and index, so makes sense. That can be just this, right? If this and temperature temperature at I-1 is greater than temperature. First of all, if Ti is equal to Ti, otherwise we make extra iterations, I believe, like here. If Ti plus 1. Ti minus 1 should get Ti plus 1. VFS we should in place T I minus 1, I minus 1. If I plus 1 is less than n, and this happens, this happens, this changes, this changes. Am I right? I think I am. Everything is C++ 17, right? Rank number of time, yes, because it does not know about deduction. Is that it? That's it. Double? Yes, infinity is double. That makes sense. Answers are 15, 14, 15, 16, 16, 17, 36, 35, 34, 33, 32, 31, 30, 31. Wait, temperature can be set to... like, well, okay. Yes, now this works. 1, 2, 3, 4, 5 also works. 5, 6, 5, 6, 6, 5. Also sounds like it works. Okay. No, but I just wasted 47 minutes of my life on 5 boring problems. Well, what's the trick here? And I am only 300 something-ish, because this is just speed forces at this point. Okay. Yeah, like normal people skip AE. I don't have much time if I want to be competitive, but I will have more time because of the order which I used. FRA stabilization GCD version? Oh no. This is a problem that I have not solved, and I did not read the editorial for it. Okay, we are given an array of positive integers. In one step array is replaced. We make some operation. New array is being built from arrays such that BI is GCD of 2 consecutive elements. Okay. Let's think. Need to be smarter than dumb for this problem, which is already problematic for me. But I don't think that you have to be particularly smart. Let's see if I'm right or if I'm wrong. So, I believe that because of how GCD works, all elements of the array will become equal to GCD of all numbers. Does it make sense? Because if some g divides all numbers, then it keeps doing this after the operation. And if some g prime does not divide all numbers, that it won't divide them after the operation, because there was a number somewhere that it was not divisible by it, and both numbers around it will become not divisible by it. So I want to say, but I think it's wrong. No, it's wrong. It's easy to construct a test case when I'm wrong. Like imagine a single one and then a bunch of twos. For our convenience, let's say that it's structured like this. So you can clearly see that like the ones. Oh, even not that quickly, like, no, just here. Here or not here? Well, up to rotation, the array will be growing like that, dying very slowly. And you can't simulate, therefore you can't simulate. Okay, new plan. Factorize everything up to 10 to the third. Okay, new plan works much better because numbers are up to 10 to the 6. You start thinking why. The answer is very simple. Because they don't want you to have problems with factorization, you can just factorize naively. Good. What do we do next about it? I want to factorize all numbers. I'm not sure what to do with the results. Okay, well, let's just say that we have vectors of pairs okay, at least that's more interesting, right? Not from here, but rather from here. D0. So fi back second plus and fi is divided by d. If ai fi push place back if ai greater than 1, of course. 1 ai equals 1. Destroying array. Not very good, but still should work. Okay, now for each we got some power sequence, right? It is, I don't know, like let's say we have a number 2 and we know its power sequence. So GCD will have power 0, which is minimal, and the time for this change to take over the entire array is what? How many prime numbers up to 10 to the 6? Too many. Too many. Okay. Why is this so okay? Like I kinda understand what's going on, but implementation is again bad. Honestly. Want to know minimum power for each prime divisor that there is. So, how am I going to do that? Maybe writing this in Java and caring about performance. So this way we computed for all prime divisors, computed what is the minimum power that will correspond to the power of this prime divisor in the GCD. And we want to compute some maximum over all prime divisors of the following level. So like we already talked about the have that power of 0 will grow and take everything with it. So what we want to find is we want to find for each prime longest subarray with powers strictly greater than max, than minimum power of that. And of those things, we want to take maximum something over 2-ish. Let's think 3 takes 2 turns, so maximum plus 1 over 2. Problem is, of course, that we can't iterate over all divisors and then over all elements. And also another problem is that this is circular or disgusting. Okay, if you think about it carefully, you can be very lazy. And I think we will be, because still something. Can't believe this. Okay. But that is just so terrible. Okay, map from prime divisor to length. Then we do the following. Because it's circular, I think we need to do the following, so that we include all subarrays possible. So, for divisor power in factors I modulo n, if MPD is less than P, ML at D gets incremented by 1. Else, ML at D should get 0 and MX should get maximum of MLD and MX. Unbelievable. Is this my output? 1 0 1 0 1. How did this happen to be 0? Oh. What if I say it here? Because this way I'm guaranteed to get it, right? At some point. If it ever increases, it's immediately counted. My answers are still wrong. So here, for example, answer is 2 0 1 2 and 1. Why the answer is 2? Pretty confident that minimum power. Oh, because for everything else I have to clear the map. Like, if there is okay, just so bad. Why, you may ask? Because this way we should be able also to do the following. We iterate over this. Oh, we can't change map while iterating over it. We can't change size. I can't. Okay. I am angry. Okay. It sounds like too much. Keys that are 0 should get removed from the map in order for this operation to work quickly. Okay, so what do we do next? For divisor length in updates. Speaking of which, divisor length. If not length, max erase ml, no, else ml d gets l. One. 0, 1, 1. Why the answer here is 1? Four, 6, 4, right? Oh, maybe it's not that bad, right? Yeah. So this line is wrong. We should just output a max. Because we already actually talked about this, probably not a max, but how can it possibly be 4? Oh, here is the answer. So the answer is still 2 for some reason. 0, 2, 1, 1. Why the answer here is 2? Let's think. 16. What is 16? maximum this way. What is 16? 16 is 2 to the 4th. What is 24? 24 is 2 to the 3rd times 3. 10 is 2 times 5. 5 is 5. So because we computed minimum power of each prime divisor incorrectly. Fantastic. Because we started here and we said like, oh, it's divisible by 2, divisible by 2, divisible by 2, and here we just don't iterate over this pair. Worst, okay, my previous claim about worst implementation ever was wrong. This implementation is even worse. So updates, overmap. Original, this is this. So here, updated D gets minimum of this and this. Makes sense. So dp in updates if p, if not p, then p erase d, else mp d equals p. As soon as we get rid of zeros, they remain zeros forever. Yes. We have to get rid of zeros for them to not make our complexity garbage. Three 0 2 1 1. I get TLE with so many maps, but like this is just to keep up. We may change some of them to unordered maps if we need to. There's no way it's gonna work. Does not look like it's going to TLE just yet. How safe is it? Out of 4 seconds. Okay, so time limit for this problem is actually raised, which makes me believe that it won't get worse 4 times. Yeah. Just being terribly slow. Actually, not that slow if you think about it. It took me 26 minutes to solve this problem, which is a bit longer than 16. That's than 17 that Ariane took. But +1 is +1. Should not have those in your code. So yeah. I actually don't know how my friends managed to solve C. It's fairly impressive. Maybe there is a greedy strategy that I completely overlooked. Who knows? Okay. Problem G, how many paths? We have even a directed graph G which can contain loops, edges from vertex to itself. Multi-edges are absent at G, which means that for all ordered pairs, uv exists at most one edge from u to v, vertices, so it's directed. Yes, it's directed. Vertices from 1 to n pass from u to v sequence of edges, blah 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 blah. Empty sequence of edges is a path from u to u. Makes sense. For each vertex v, output one of four values: 0 if there are no paths from 1 to v, 1 if there is only one path from 1 to v, 2 if there is more than one path from 1 to v, and the number of paths is finite. -1 if the number of paths from 1 to v is infinite. Okay, sounds like a textbook question. So here, 1, 1, 1, 2, -1, -1. Zero, 1, 1, 2, -1, -1. Makes sense. Why is it in this order though? Okay. Makes sense. Boring. No, that one is more or less interesting. Like, at least I will practice something. It's really good. So we read our graph. What do we do next? You want to start, no. Like, ideally you would like to find a topological ordering, but there may be no topological ordering. Another thing you may want to do is dynamic programming of the following form. Like, normally, if you can't pass and they are all finite, then if you have an directed acyclic graph, then number of paths is finite and can be computed via dp. It's good. dp in which we push forward. And in which we never push to a vertex that no, but okay. I believe it's impossible to have zero pass modulo this. So we will use it as a dummy modulo with the following idea in mind. So d of, so say root is 0, creates d of r is 1. while not BFS empty. Is it BFS or is it not BFS? It's not, right? It's not. It's too early for this, but what is not early? We have plenty of time, right? Yes. Need parents. Let's say its original parents are all negative ones. While BFS is not empty, we take a vertex from it. Cycle. If used at V, cycle of V is true. There is cycle contained in this vertex, which means that number of paths to anything reachable from this is infinite. Else, BFS no, not like this. Like you clearly understand what you want to do mathematically, but why the implementation is so difficult in this class? Oh, sorry about that. I don't want to think about implementation. I want to think about something interesting, guys. This is not a cycle. How do we do it accurately? This is the only question that I have. Need to somehow do. Okay. Let's think the following. What will happen to topo sort when it can't sort? Okay. let's write the following implementation of top sort. In degrees, right? In degrees. It has, oh my goodness me. No, but honestly, like, this is very bad content. This is a bad contest. Bad contest. Don't recommend. Void v. Degree of in degree of u increases. Now, how do you write top of sort given in degrees and BFS? Quite simple. You say like originally what can get into the BFS, into the order. Many things can, like if degree of some vertex is 0 in degree, BFS, push it into BFS. It can be in the order. Right? Then what you do is the following: while not BFS empty, say please give me a vertex so please give me a vertex, remove it from queue, add it to order for each neighbor, decrement the in degree. If in degree became 0, push this vertex into this thing. Why this works? So what comes next is vector of answers. Originally everything has infinite value, right? All right. All right. So now, for every vertex in top of order, just answer at vertex equals 0. If vertex equals root, which we no longer have, okay. If not vertex, answer at v equals 1. Oh, okay. We also need a reverse graph. May as well use it for degrees. Why? Because we are going to iterate over all parents of this vertex. Makes sense, right? Right. And we are going to say that answer at vertex should get incremented by the answer here and modded. Now modded just because it's quite easy to construct a test case when the number of paths is the power of 2, which means that it may get 0 if we don't mod values and just let them overflow. So now can they can't become 1? No, okay, trick with modulo is a bad idea. It's most probably hackable. So we increment by this. If AV is greater than 1, AV is 2. Intellect plus 100. I don't care. Like some warnings are important and some are not. 1, 0, 1, 2, negative 1, negative 1, 1, negative 1, negative 1, negative 1, 1, 0, 0, 0, 1, 1, 2, 1. Okay. No! No, we almost got the contest accepted without. Wrong answers. Okay, how are the boys doing? Surprisingly enough. Oh no, that's fine, that's fine. The idea is with this implementation, vertices that can be that are in a cycle, including loop cycle to itself, will never make it to the order. Will never make it to the order. Oh, okay, I know what's the trick. Like imagine a disconnected cycle, right? Disconnected, 2 disconnected cycles. Should have got it. Should have been more careful, no? Okay, simplest way to create 2 disconnected cycles. 2 vertices, 1 edge. One edge goes from vertex 2 to vertex 2. The answer that our code produces on the last sample is 1, negative 1, whereas this negative 1 should be actually 0. So what are we going to do? Okay. We need to run another BFS to make sure what vertices are reachable and what are not reachable. If the vertex is not reachable, then we explicitly will set its value to 0. While BFS is not empty, we take a vertex from BFS, we say okay, pop front. You used at vertex gets true. Used at vertex gets true when we add to BFS. For adjacent, if not used at adjacent, let's make it true. Does it matter? Yeah, I think it does. Let's say BFS pushback W. Oh, this is tricky. So for all variables, if not used at I, answer at I gets 0. Let's compile without warnings. Oh, I cleared. Okay, we remember what should have changed, right? Yes, this number changed to 0, as it should have. Let's submit once again. Well, we have found at least one offending test case. Better than no. Okay, still wrong answer. Fascinating. Oh, no. No. I set to 0. Well, like the answer for all vertices that are not reachable from root, which is exactly what I should. Then I loop over all vertices in my topological order, and I say the following. So, original vertex gets 0. With the following idea in mind. If it is a starting vertex, then we have to set it to 1. Because if it's in topo order, then it's not in a cycle. If it's not in a cycle, there is only one way to reach root, and that's do nothing. Then for all edges in reversed graph, for all my parents, I say that number of ways to get to me, you can compute it by summing the numbers of ways to get to my parents. And whenever this becomes at least 2, it stays 2. And answer at my parent can't be -1, because then it would never make it into topo order, and if my parent never made it to topo order, then me neither. So what's wrong? Graph, reverse graph. How are the boys doing? Fascinating. Quite upsetting, actually. I should open it like this, because this way I will see the time. The only downside of having like all problems opened is that you don't see the timer, because it's not relevant during the first stages of the game. So negative ones, I took care of them. They are originally everywhere, and if you are not in the if you are not in the topological order, then you got -1 for a reason. If you are not reachable from 0, then you get 0 for a reason. I just want to quickly check something. Where is my top order? Is it somewhere here? Oh, I don't have a top order sync. Oh. But I'm pretty sure that this works as it should. If in degree is 0, then this is a starting vertex for topo sort. Push them back. So I will process vertices in topo order, meaning that all edges go forward. And when I come to a vertex, I can be sure that all its parents were already processed. I increment the number of ways to get to these vertices. If it became greater than 1, I said that it's just 2 so that it never overflows. Just sanity check. My parents was already processed. But I don't see a mistake. I don't see a mistake. We can use another submission just to check if this ever fails, but I don't think that it's enough to resubmit. It's not justified. Let's think again. We process some test cases. Be sure to never use variable t. We don't. Good. We have n vertices in our graph and m edges. Both vertices are from 1 to n. We read a pair of vertices, we decrement them by 1, we push a forward edge in forward graph, backward edge in reverse graph. We compute all the degrees in degrees as degrees of reverse graph. And our plan is to compute topo order. We do it with BFS in the following way. If degree of some vertex is 0, we push it into the BFS. While BFS is not empty, we take a vertex that has no incoming edges, we can put it to the topo order. We should decrease for all vertices that this vertex has an edge to, forward edge, we decrease their in degree. If it became 0, we push it to BFS. And originally all answers are -1, signifying that all vertices that did not get to into the topo order, they have, if vertex is reachable from 1 and it did not get into topo order, it means that this in some sort of cycle, making the number of paths infinite. Originally, we assume that all vertices are as such. When we write a BFS to find the number or to find vertices that are unreachable, how do we do it? Boolean array, 0 vertex is reachable, while BFS not empty, take vertex, and go to all neighbors. If neighbor is not visited, mark it as visited and push it to BFS. For all vertices, if it was not visited, the answer is 0. And if we compute number of ways in topological order, the identity element is 0. If this is a starting vertex, then there is one pass, because if it got to top order, then there is one pass. And when we loop our parents of this vertex, we say that we should add number of edges. We shouldn't add number of paths. So this gets added this. If it's greater than 1, then we set it to 2. Because if we ever add 2, then here it will become 2 as well. I don't really know. Like, we did not change anything in our code, so it can't get accepted. I'm completely clueless about what went wrong. Oh, I probably don't want to do that. Okay, if we submit, we waste a submission, but we get to know if this sort ever fails, because then it will be runtime. Okay, this sort never fails. Let's make more sorts. I know it's quite wasteful, but how else do you extract information from testing system when you have no idea what went wrong in your code? Wrong answer. So all assertions hold, meaning that one of our answers is incorrect. How about we say that these are negative 2's? No, but then it just does not make sense. I don't get it. 250 people got it. What am I doing wrong? What am I doing wrong? If we have two edges like this, then we don't care, I think. They will just never make it to top order, because in degree will be 1 for both of them forever. I don't get it. What's wrong? Oh. This is valid, right? And then I have only one pass. And this is only one. Like all that we do is we crop, right? So we crop. Like if the value is at least 2, then set it to 2. If we ever add this 2 to something further up the road, it will become 2 as well. So what the heck is going on? What is going on? No, it's just so textbook. What can I be possibly getting wrong? Top order is only necessary to perform our DP in correct order, if you may call it a DP. So confusing. I just don't get it. Like this code can't possibly be wrong. I read it 2 times already and I see no reason to not trust it. What is the reason? This is correct, like we already talked about it. If we are in a topological order and we have some incoming edges and all those edges were processed before we were added to topological order, so all our parents are before us in the topological order, we can use their information to compute our information. I don't understand. I don't understand. Everything is so simple in this code. Why is it wrong? Why is it wrong? Why is it wrong? I already... Okay. I compiled it with warnings. It is only disappointed on line 18 where I compute this. I can understand you, but that doesn't really matter. So, why am I getting the wrong answer? So frustrating. Should I just generate a random graph? I don't know. Let's say we have, I don't know, 10 test cases. Say our first graph has 6 vertices and 9 edges. Let's just start. Why have I done this? So tilted right now, and I just don't understand. Like, it does not sound fair. If you know what I mean. Sounds like I did something wrong. I have no idea what I did wrong. I have no idea. Okay. Oh, I accidentally found the incorrect thing. Okay. So I'm quite stupid. Sad. What can I say? It's quite sad. So first, we compute all vertices that are unreachable, because we should exclude them from topological order. Don't care if they get into topological order, if not, if they are unreachable. It's just so lame. Okay, but that makes several problems for us. For example, fuck, why is this so sorry, but it's just... Implementation is annoying again. Who could have thought? But but and so tilted. I should not be that tilted, but it's just impossible. So if not A, V, date push back V to V in update. I can't erase from set while iterating over it, so I have to use that terrible workaround. Then I have to use it once again for reverse graph. That is just ridiculous. And then I can do my normal sync. So okay. Should probably also test on this. This probably should get added here. So yes, okay. That debugging technique did not pay off with trying to get a runtime error when some of your assumptions don't hold. Unfortunately, did not pay off. Runtime, what? What? Excuse me. Oh, because, okay, okay. Why did it not work then? Oh, because it was not getting, okay. Here is not equal to me. Well, that assertion was actually useful. I just finished saying that it was did not pay off and stuff like that, whereas in fact it got. Think it. What? Wait, how I still I don't still wait a second, how did it happen? Answer at parent of our current vertex is -1. Well, no, let's think again. So first things first, we loop over all. We find who is reachable, who is not reachable. If the vertex is not reachable, we set it to 0. Then we loop over all vertices, over all edges, and we say like, if this vertex is not visible, it's not reachable, then let me kindly delete it from you. Same go, like first we remember that we want to delete, then we actually delete it. Okay, then we do the same with reversed graph. Okay. Then we say like, we now only have reachable parts of our graph. Oh, if not degree, if AI and not degree, right? if the vertex is reachable but does not have any in degree. Oh. First time we got that far. Well, that is of course very sad. I spent so many, more than half of my submissions in this contest go to one problem. Questionable result, of course. Penalty will be insane. Also takes quite slow on. Time limit is 4 seconds. Okay, that was an interesting debugging exercise. And our assertions actually proved to be somewhat useful. Somewhat because the correct way was not to make the mistake and not to use assertions to catch it, but well, at least they have 50 or so tests. Imagine getting like TLE 111. Happened several times. Not to me, however. Maybe to me as well. Okay. I will get it, but I will be very last who got it. Running on test 60. Imagine it's actually TLS and I have to, okay, I will start making some changes. Assertions take some time. They are not particularly slow, but they do take some time. What else can be simplified? Set, unordered set. Nah, one. For the purpose of evaluating an ordered set versus set, let's do this, and let's also take our submission for F and change map to an ordered map for F. Yeah, definitely not a video that you expected to see. We will be very last who got it. No, actually, despite our terrible million minutes of penalty here, yes, so for G, the difference between set and ordered set was not that significant, I assume, because we had quite some work in BFS. Yes, we could have definitely made a better job here. Just not how you perform well. And for F, actually, an ordered set is not faster. An ordered map is not that faster than map. I assume because you just erase too much. That's why. Okay, Okay. V is having troubles on A. What did we do? Oh, I can relate. Let's put it this way. The morning was better than the evening and then the afternoon, in fact. But hey, at least we got all the problems. Should we quickly go over them? I bet that someone like Galen Cohen will do it either way, but no. So here map was actually faster. So A, implementation. You had to notice that the only time when blocked cell increases shortest Manhattan pass is when they are on the line, because otherwise, if you have this cell, and blocked is somewhere in between, you can always walk over it. You say like, okay, what if the blocked cell is here? You can always walk this way. So there are two non-intersecting shortest paths between those things, so one cell can block them both. If the cells are, however, on the same horizontal or vertical line, then a blocked cell in between block is the only shortest path and you have to go around. And going around is exactly 2 units longer, this and this. That's what we check. We just write a condition that checks if the configuration is as such or as such. Terrible problem, would never advise it to a friend as a practice problem. Here, reverse the order of operations, quite common thing to notice. You say like, okay, let's remember let's think what happened last. Last was some character, we know which character it was, we know it was appended to the front or to the end. Let's simply check if it was appended to the front, pop from the front, if it was appended to the back, pop from the back. Otherwise, it's impossible to have a situation where this character is neither first nor last. So here I almost guaranteed that I overcomplicated it. But my solution is as follows. So I will compute the length of the file after I and j operations, I from polycarp, j from monocarp. I will always also compute what is the parent, that is who made the last operation. And dpij will be -1 if it's impossible to make those operations. So, because if it's possible, the order does not matter. Like who you choose, if both parents are possible, doesn't matter which one you choose, because both are possible. Then you just check that it's possible, and if the parent is possible and current operation is possible, then we make it. Same here, same here, same here. And if it's not possible overall, it's not possible. Otherwise, we restore pass by taking our parents and we print pass in reversed order. Here, bitwise operations, you just need to observe that your sequence is factually predetermined. If you want to minimize it, then you don't want to turn more bits on than necessary. And which bits do you have to turn on? You know which ones, because the previous entries tell you. Here, use Dijkstra because we can. Should have used BFS, there's probably a linear solution to this, but we don't care because we can use Dijkstra. And trick hackers by saying that it's BFS. Then F, number theory problem, you wanted to think about divisors. Numbers are small, so have few divisors. You can factor everything. You can work with divisors, with all pairs of element in its divisor. And you just make a lot of operations with those divisors. Realize that like I should probably have mentioned this, but imagine that the powers of 2 are as such. We have this situation somewhere. What's going to happen is when you take consecutive GCDs, that block, which has more 2's that it will have in the end, it will shrink. Everything else will be 2, 2, 2, and then it will shrink again, and everything will be just 2. So the time it takes to shrink is the length of this block. So we just need to compute the length of longest block, which has degree bigger than minimum. So we need to compute minimum degrees, which we did here in a very obscure way. But ideally, I want to update map. I want to clear entries when I see this. Erase. But I can't because we are iterating over a map. It's illegal to change map while iterating over it. So I just cache updates. To be consistent, I also cache updates here, despite that I don't need to. Then I also cache updates here because I need to. I again want to clear. Without this clear, the complexity is quadratic. With this clear, for entry to get into the map, you need one pair element divisor, and there are n log n pairs of element divisor because of how divisors work. Like one element, n log max a, and max a is not particularly big. So yeah, that update is technique to cache updates, and that's it. Probably it's best to use vector of pairs, but I'm not that smart. Here I just made too many mistakes, but the idea is as follows. First, remove everything that is not reachable from the graph. Then you want to, like, imagine that you want to actually calculate the number of paths. Then you want topo order. Now they may not be a topo order, in which case all vertices that don't get into topo order they have infinitely many paths going to them, because they are a part of some cycle. Now finite cycles is not particularly nice, so what we do instead is we find topo order with BFS. Now, you already heard me experiment it several times. Have to do it with to find topo order with BFS. The idea is you add all vertices in degree 0, and you maintain in degrees. Whenever you see a new in degree of 0, you go ahead and add this into potential order. At some point you will add it to order. So one with reachable vertices out of the way, you also had to update to clear everything extra from graph. Again, can't change a graph while overwriting over it, so have to cache updates. This time I used vector because why not? Because I know that there will be only one update. Like here I was actually not sure. Maybe one update happens here and one update happens here for the same entry. I have to somehow think about it. I don't want. Once you have your order, you can do your simple DP, which you usually do is increase by the answer by answers of all parents. Except for here, values may overflow. Modding does not technically work. I believe that there are ways when 2 gets to 1. There are no cases when the number of ways is divisible by 10 to the 9th plus 7, but there may be cases when it's 1 modulo something, and we actually need it to be 2, so I decided we just clip. Whenever anything gets bigger than 2, we just set it back to 2. Because whenever this 2 is propagated further, it still acts as like more than 1, which is important. So it was important to do those things in correct order. Unfortunately, we did not figure out it immediately. which leads to unbelievably high penalty. But that's how the life goes sometimes. Yeah, like normal people just solve everything quickly. Oh, yeah, he actually also made some mistakes. So he was much faster in implementation or something? Also, why is he my friend? So he was just much faster in implementation. I don't know, for me as a competitive programmer, it's bad to say the following thing, but for me as a person, I find it justified to solve to solve problems that you don't like longer than you should. Because this is not what I want to do, to solve problems that I don't like. I believe that at some point there will be a contest which I will enjoy. If it's not, if for quite a long time I don't see a contest that I enjoy, then probably I'm doing something wrong and I should not do competitive programming at all. But like today in the morning, it was absolutely dumb contest on Hacker Earth, but there was no competition, but the problems were rather nice. I think. These problems I don't enjoy them, so. Well, it's good to know that you have to perform several operations in specific order, but does it really teach me anything beautiful? No. Will I make the same mistake in rated contest? Most likely yes, at some point. And I will also spend some time debugging it. So I'm not proud of it, but I'm also not... I don't think that I should be disappointed at myself or say like, oh, I should have got it faster. No, I don't own it to anyone. I should solve problems that I like faster, that's for sure, but not such problems. So that's it for today. I did not upload that coder yet. Probably should, but that's it for now, and see you next time around, which won't be tomorrow, despite I will take part in CFDIF1, because I find it a bit distracting to record a div1 contest. It didn't go well several times in the past, and I don't want to experiment further, let's put it this way. Even though I will probably bounce back in any div2 competition, but that's still not something I want to do. So yeah, see you next time, which hopefully will be soon. Bye bye.